Functions in Python are that block of code which you need to define once and you can use it as many times as you want in your programs. And in this whole module, we will be discussing about functions, that how we can create a function, how we can create a Lambda function, how we can create a recursive function, what are parameters, arguments, and so much more. So hello everyone and a very warm welcome to WsCube Tech. My name is Ayushi Jain. And as we discussed in this video, we will be discussing about functions. Before that, if you want to become a successful data analyst and if you want to learn data analytics live from our experts, then you can call on the number provided on your screen or you can click on the link provided in the description. Now, let's get started with the video.
So today onwards, we are starting with a new topic, that is the functions. So we will be discussing briefly what are functions. First of all, let's understand what are functions. Functions are nothing that they are set of codes which we only need to write once, which we once create. It can be used inside the program as many times as we want. Now, what is the advantage of a function over here is that functions helps break our program into smaller parts and helps it look more organized and manageable. So when we are creating a huge program and if we are using functions inside it, it would be very easy for us to debug it. Plus it looks very manageable and aesthetic as well. So we will be first discussing how a function can be created. So guys, when we create a function is divided into two parts. First is defining the function and second is calling the function. So I'll be writing over here. Function is divided into two parts. First is definition of function and second is calling the function. So guys, this part defining a function, define a function means that what our function is supposed to do. It comes in a category of this part, that what our function is supposed to do. And secondly, once we have defined that what our function is supposed to do, we need to call it in our program. Until and unless we don't call it in our program, our function will not work over here. Even though if we have defined it, but if we have not called it in our program, it won't work over here. So let's see how a function can be created. For example, if you want to first create a definition of a function, that we are defining a simple function over here. So guys, defining a function is very simple over here. All you need to do is write DEF. DEF is the short form for definition, that we are defining a function over here. What function we are defining, that means what is the name of our function. Let's say any variable it is. So I'm just writing variable. And then we use the open close parentheses over here followed by a colon. Inside the colon, we write the body of the function, that what is there inside our function, what our function is supposed to do. So this is the body of function. Once we have written the body of the function, the next part would be calling the function. To call the function, all you need to do is write the name of the function. Let's say the name of the function is variable and open close the parentheses. This is how your function will work inside the program. Even though if you have created this part but you have not written this part, your function will not work. Now let's see how it can be created inside Python. So guys, as I told you that there are two parts over here. First is defining a function and second is calling a function. So first of all, let's define the function. I'm creating definition and let's say I'm creating any variable over here, like let's say hello, and I'll open close the brackets. I'll put a colon over here. The variable name doesn't need to make sense. You can write any name over here, but if you write something that makes sense, then it would help you throughout the program. So I'll be writing definition hello. Inside this, I'm just printing hello world. Right now, if I run this program, I will not get any output. Why I will not get any output? Because as I told you that this is just the definition of the function. This is just there, that what is there inside the function. To use it in our program, we need to call it. So how to call a function in our program is very simple. All you need to write is the name of the variable, that is hello, followed by the parentheses. Now if I run this function, I will get the output hello world, which is there inside the body of the function. See guys, this is how a function can be created. Now let's quickly get started with what we have in our today's session. So here we have parameters and arguments. Now guys, what is parameters and arguments? Let's discuss that. So guys, parameters here are nothing but they are the name of the variables that we need to use inside our functions, and they are written after the name of our function. And arguments are nothing. Arguments are the values that we pass to these parameters. That means these variables that we write in the name of a function. So let's see how these parameters and arguments are written inside a function. So guys, as we all know that first of all we have a function, and function is categorized into two categories over here. The first is its definition, second is calling a function. So the definition part has the parameters and the calling part has the arguments. Now for example, you have created a function that requires some variables inside it. Let's say I'm creating a function def and my function's name is people. Here I need some variables like their name and age. So name I'll be writing comma age. So these name and age over here will be termed as our parameters. Now guys, there are two types of functions, parameterized functions and non-parameterized functions. So if you ever hear this term, don't get confused with what is parameterized function and what is non-parameterized function. So parameterized functions are basically those functions which have parameters, and non-parameterized functions are those functions which do not have parameters. Coming back to our topic over here, so we write the parameters over here, we write the body, that what is there inside this function, and when we call the function over here by writing people, we provide the age over here. For example, let's say the name is John over here and the age is 23. So this prints the output with the arguments, that means the values that we have provided over here. So these are the arguments. Now let's use parameters and arguments inside our Python program. So guys, I'm creating a function over here, that definition people, and I'm creating the two parameters over here. My first parameter is name and the second parameter is age over here. I'll put a colon and I'll write print my name is comma name and I am comma age years old. Now what I will be doing, I will be providing it with the argument. So if I write over here, so when I call my function and along with calling the function, if I pass the values as the argument, that is, let's say the first one is John and comma, the second argument, that means the value of the second argument will be returned over here. So I'll be writing 23. As soon as I run my program, you can see it writes my name is John and I am 23 years old. Guys, we also said that function needs to be created only once and then you can use it in your program as many times as you want. So here arguments allows us to use a function with the different values as well. Suppose if I write people over here and provide it with the different values. Let's say my first name is Lisa and her age is 24. And if I run it, it will again give me with the output, but here this time the name has been replaced with Lisa and the age here has been replaced with 24. So guys, this is how our parameters and arguments work inside the function. So let's consider another example. I'm creating another function over here. We will be applying a mathematical function to it maybe. So I'll be creating it for the area of rectangle. So I'll be writing RECT. And here I'm taking two parameters, that is the length of it and width of it. Right. After this, I'll be writing the area. So print the area of rectangle is comma length times width, and to call the program all I need to do is write RECT and provide it with the values, let's say 3 comma 5. So 3 times 5 will be 15, and if I run it, it gives me that the area of the rectangle is 15. So guys, this is the way in which we can write parameters and arguments in our functions. Here in the first function, the name and age is the parameter and the values that we have provided to it while calling the function, that was the argument. In the second one over here, the length and width is the parameters and the value that we are providing it while calling a program, that means 3 and 5 over here are arguments. Today we will be talking about the return statement and recursion in Python. Let's first understand what is return statement. So guys, return function in Python is nothing but it is used to exit a function, and it stores the value of our function inside it and it returns it in the end of the function wherever we are calling it. So let's see how a return statement can be used in Python.
Before that, if you want to become a successful data analyst and if you want to learn from our experts live, then you can call on the given number or you can fill the form that is provided in our description. Not just that, with our every batch, you will be getting 2 demo classes for free.
So guys, here I will be taking an example of a function. I'll be writing definition, and just like how we write hello, and I'm calling this function's name as a hello, and inside I'm not keeping any parameter, just writing it in this way. Inside I want to write print hello world, And if I want to call it, all I need to do is write hello and open close the parentheses. This is how we generally do. Now, how to use a return statement to get this hello world over here? All I need to do is write over here return hello world, and then I can write in the end to call the function print hello. And if I run it, yes, it will do the same thing that our normal function would do, but this is how return stores a value inside it, and then whenever we want to get it, we can use the print statement to get that value. If you want to see another example over here for, let's say I'm gonna take an example to add two numbers over here. So definition add, and let's say these two variables are x comma y, and I'm gonna write return x plus y, and whenever I want to get the output, all I need to do is write print a and pass the values to these parameters. So let's say I have 3 comma 8. So as soon as I run it, I get the output 11 over here. So guys, this is what return statement is doing over here. It's storing the value of the function inside it, and then whenever we wanted it, we can use the print statement to get the output over here. So guys, here I hope what return statement is pretty much clear to you. So guys, talking about now what is recursion? In simple words, if I explain you what recursion is, that recursion means it's a function that calls itself. It allows us to loop through the data and gives us a result. That is recursion basically. So in Python, recursion is not like this, it is mandatory to use, but yes, if you use it in your program, it has several benefits as well. So we will be first learning about how recursion can be used in our program, and then we will be talking about its advantages and disadvantages in Python. So let's see first what is recursion. So guys, if I take a example of a simple function over here, if I write definition hello, and I'll open close the parentheses, put a colon, and inside we write print hello world. Okay, and if I want to call this function, all I need to do is write hello and open close the parentheses. If I run it, I get the output hello world. Okay, what if I want so many hello worlds over here? What if I don't want only one single hello? I want many hello worlds over here. All I need to do is, yes, you're right. We can use a loop over here. Any kind of loop we can use to get multiple hello worlds. But we are learning about the recursion, so let's understand how we can use recursion over here to get multiple hello worlds at the same time. So guys, recursion means looping through a data. Recursion means when a function calls itself. Python allows us to perform this function when a function can call itself. So here, if I want to call this function itself, all I need to do is write hello and open close the bracket. So here what will happen if I run this program? If I'll scroll up, you can see there are so many hello worlds, and in the end it's throwing me an error because of the limit that got exceeded. So it says previous line repeated 993 more times, so there must be some limits over here that okay, this much times only this thing will loop. So okay, basically let's understand first what is going on over here. So what happened basically over here, I created a function in which I wrote hello world, and inside it I'm also calling it. So I called it outside, and when I'm calling it inside it also there is hello world. So it's repeating, and inside, so when I'm calling this, it's printing this hello world, but it is also calling this function again itself. So again it's printing hello world, again it's calling itself, and again it's printing hello world over here. So this is what basically is going on over here. This is what recursion is. That means when a function calls itself. So now guys, you must be thinking that where this recursion can be used. So let's take another example over here where I will be finding a factorial of 8 by using recursion. Now let's understand what is factorial of 8. Factorial of 8 would be 8 multiplied by 7 multiplied by 6 multiplied by 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. Right? This will be our factorial of 8, okay, which will give us a result 40320. Okay, now what we need to do over here is, with the help of the recursion, we need to find the factorial of 8. So factorial of 8 can also be written as 8 multiplied by 7 factorial. Then factorial of 7 can also be written as 7 multiplied by 6 factorial. factorial of 6 can also be written as 6 multiplied by 5 factorial and so on, right? Okay, we will be keeping this thing in our mind. So talking about the function over here, how this recursion will happen inside a function. Yes, you can, yes, you're right. You can, if you think about using a for loop over here, yes, for loop can be used where we can provide it with a value. We can create a variable, let's say 1, and then we can loop through it and multiply all the numbers. Let's say if you want to find factorial of 8, you can take the starting value as 1, ending value is 9, and you can multiply with all the numbers, right? That can be done, but here we are using recursion, so let's understand how recursion can be done. Every time we know that our value is increasing by 1, so let's consider a value a is equals to, initially a is 8. In this method, what is happening? A is there, a multiplied by a minus 1 factorial is happening, right? In the next time, if it is 7, so for 7 also again we have a multiplied by a minus 1, that is 6 factorial over here, right? And it keeps going on, so on. So we will be using this formula over here inside our function, that a multiplied by a minus 1, that every time its factorial is decreased by 1, but so till when it will be decreased? When we reach 0 over there. Suppose if our value is 0, when a becomes 0, in that condition, what will happen? We will return the statement by 1, that we will be putting 1 over there. We will be multiplying it with 1. So let's put it inside our Python program and see how it can be done. So guys, what we will be doing over here, we will be creating a function definition factorial. So for factorial, I'll be just writing FAC and I'll be giving our parameter a over here, right? Okay. We know that we want a value over here. We will be using our formula that I explained to you previously. So to get it, all I need to do is write return. And what I want to return, a. Every time a will be multiplied by factorial of our previous number. So I'll be writing FACT. And previous number would be a minus 1. Right? This will be our formula that we will be using to fetch the factorial of a number. So till when it will be using? Till the time our a's value is equal to 0. So as soon as our a value is equal to 0, in that condition we will return 1. Now let's write it over here. Let's print it. That print FAC of 8. If I run this program, I get the output 40320. And if you remember, here also we have written 40320 as a factorial of 8. So guys, this is how you can find a factorial of any number. If you write over here, let's say 4, you get the factorial of 4, that is 24. Similarly, you can change the numbers and get the factorial of any number. This is how recursion can be used. Recursion can be a bit tricky. It is difficult to use recursion in a function, but with the practice, it can be of very much of use. So coming to the part about how recursion can be useful to us, what are the advantages of the recursion, what are the disadvantages of the recursion, let's talk about that. First of all, it makes our code look organized. Yes, in a very small 3 to 4 lines of code, we created a factorial of any number. So yes, it makes it look elegant. It makes it look more organized. We know that what is going on over there. Second thing is, by the use of recursive function, a complex task. So this was a complex task to find a factorial of any number, but we broke it into a simple problem. We created a small formula to find it and we got it, right? With the help of the recursion. Third thing over here is sequence generation becomes easier. So when you are working on any mathematical sequences, you can use recursion. Recursion can be very useful at that time. But you just have to be careful about the formulas. Next is talking about the disadvantages, that what disadvantages we have of using recursion. Recursive function can take a lot of memory. So sometimes what happens when you're using recursion, recursion means it's looping the whole data, right? It's looping through the data. So it's storing all the data inside the memory while creating a complex program, while creating a huge program. If you use recursion, it takes up a lot of memory. So that is one disadvantage. Second disadvantage we have of recursion is sometimes the logic becomes hard to follow. We can see over here also that yes, we took a factorial which was a very easy logic, but sometimes it becomes really difficult to follow the logic and it becomes very hard for us to use logic in recursion. While if you do it simply by using any other method, maybe using loops or any other things, that would be much more easier than the recursion. But yes, at the same time, recursion, if you understand recursion, then it can help you a lot. It can make our complex problems very simple. Third thing over here is it is difficult to debug the recursive functions. Yes, recursive functions are very, very difficult to be debugged. So these are few advantages and disadvantages that I have enlisted about the recursive function. In our today's session, we will be discussing about the Lambda function that is used in Python. Now let's see what is the Lambda function over here. So guys, Lambda is an anonymous function. It is used for a very short period of time. Lambda function can take numerous amounts of arguments, and at the same time, inside the Lambda function, you can only use one expression. So guys, to create a Lambda function, all you need to do is, for example, I'm creating a variable called as A. A is equals to, I'm going to write lambda B colon. Now what I'm going to do is I'm going to put a value of B. I'm going to use an anonymous value of B over here, that B when multiplied by 5, what output does it gives us. So I'll be writing print A, that is the name over here of our variable, and inside it I'll be providing with the value of B. So I'll be writing 12 over here. As soon as I run this program, I get the output 60 over here. So this is how our Lambda function works, that we create an anonymous function over here inside a function only. And here in this function, I have taken one argument. Let's try how we can do it with taking two arguments. So at the same time, if I'm taking an example over here, z is equals to lambda. I'm taking two arguments over here, that is x comma y. And I'll put a colon and I'll be multiplying this x and y's value to each other. So I'll write x multiply by y. And if I print in the next line, print the name of our function, the name of a variable over here, that is z, and inside it I'll be providing with the two values, that is of x and y. So let's say I'll be writing 5 comma 8, and if I run it, I get the output 40 over here. So guys, this is how a Lambda function is used. I hope you guys have no doubts and no questions. In our today's session, we will be talking about the local and the global variables. So guys, coming back to our local and the global variables, we know what are variables. Now guys, variables are further categorized into two categories in the functions, that is the local variables and the global variables. Let's first understand what are these variables. Guys, local variables over here are those variables which are restricted to one block of code. Now, what does this mean? That if you have used a variable, if you have created a variable outside the body of the function and you use it inside the body of the function and try to change its value, it will not work. It will remain the same that it was there outside the body of the function. So that is our local variables. Local variables are those variables which are not restricted to one block of code. Now what does this mean? That suppose you have created a variable outside the function and now you're using it inside the function and changing its value as well. Like you are playing with its value as well. So it will be changed when you will use it outside the function. When you will run the program, it will be changed, and to make that happen, all we need to do is use a global term over here. So first of all, let's understand local and the global variables with the help of an example in Python. So guys, first of all, in local variables, I'm creating a variable over here. X is equals to, let's say, 25, and now I'm creating a function, that definition. Let's say any random variable, I'm taking x, y, z. Okay, inside this function, what I will be doing, I will be changing the value of x over here. So if I write x is equals to, let's say, 35, and print x. Now if I call my function over here x, y, z, and open close the bracket, and if I run it, it gives me 35. If I call the variable over here, like if I write what is the value of the variable x over here, it gives me 25. So guys, what is happening over here is, even though I have changed the value of this function inside the body of our function, still when I'm printing it outside the function, it is giving me the value that was already there outside. It has not changed the value of the function. It has only been changed inside the function. It is not working outside the function. Now, how to make it work outside the function also? So the solution over here will be our global variables. So I'll be considering the same example over here, that I'll be creating a variable called as x. X is equals to 25. I'll be creating a function over here, the definition xyz, and I'll open close the parentheses, put a colon over here. I'll change the value over here, but before I change the value of this variable over here, I will be declaring this x as a global variable. So how to declare x as a global variable? All I need to do is write global x. After this, I'll be writing x is equals to 35, print x. Now if I call this function over here by writing xyz, it gives me the output as 35. Now let's see what happens when I write the variable x over here, when I print the variable x over here. So if I print x over here, it gives me the output 35, which means that inside the function, when we have changed the value of our x to 35, it has also worked outside. Now with the help of the global variable, we can change the values inside the function and use the similar values outside as well. So guys, these are about the local and the global variables. Global variables are very useful when we are using variables inside a program and we want to change the values with the help of a function. We want to create a function which changes the value of a variable by doing a certain task. At that time, global variable is widely used. So today we will be solving some problems related to the functions, and I hope if you have any doubts or any questions so far, then all your doubts or questions will be after this problem solving. So let's get started. So here I have mentioned 5 problems over here. First one says write a function to find the maximum of 3 numbers in Python. Write a function to create and print a list where the values are square of numbers between 1 and 30. Write a Python function that takes a number as a parameter, and then we have to check if that number that is there in the parameter, that means when we pass the value to that parameter, if that number is a prime number or not. Write a Python function to find the sum of all the numbers in the list. In this we will be doing it with the 2 methods, one with normal function and once we will be doing it with the recursion as well. Write a Python program to solve the Fibonacci sequence using recursion. We have already solved this Fibonacci series using loops. Today we will be learning it how it can be done using the recursion. So let's get started over here. We'll be starting with the question number 1, which says write a function to find the maximum of 3 numbers in Python.
Before that, if you want to become a successful data analyst and if you want to learn from our experts live, then you can call on the given number or you can fill the form that is provided in our description. Not just that, with our every batch, you will be getting 2 demo classes for free.
So for this, I'll be creating a function over here, definition maximum, open close the bracket. Now we know that we need to find it between the 3 numbers. So we will be needing 3 parameters over here. So I'll be writing value 1, comma, value 2, comma, value 3. So we need 3 parameters over here, value 1, value 2, value 3, and between these 3 values we need to find which is the maximum number over here. Now how we will find it? We will be giving a conditional statement over here that if value 1 is greater than value 2 and also value 1 is greater than value 3, in that condition, what we will do, we will be writing that we will be creating a variable basically, and we will be writing. So in this condition, what we will be doing, we will be creating a variable called as maximum value is equals to value 1. So when value 1 will be a maximum value when it is greater than 2 and also it is greater than 3. In that condition, our value 1 will be the greatest. If value 2, now we will be doing this for our value 2, that value 2 is greater than value 1 and value 2 is also greater than value 3. In that condition, the maximum value, that the same variable maximum value will be set to value 2. And lastly, if not 1, not 2, that means if 1 is also not the greatest, 2 is also not the greatest, then definitely our 3 is the greatest over here. So we will be writing else maximum value will be set to value 3. And lastly, what we need to do, we need to return this over here. So we will be returning this variable maximum value over here. So return maximum value in our output screen when we call the function. Now to call the function, what we need to do, we need to provide the values over here. We will be writing maximum and let's give any value 12, 56, 34. Let's print it as well. As soon as I run it, I'll get the output over here that my 56 is the maximum value over here. Similarly, you can add a statement over here that the largest or the maximum value between the given 3 numbers is, and you can close it over here, put a comma, and let's run and see. So it gives me the output in this way. The maximum values between the given 3 numbers is 56. If you want to change it to any other number, suppose if I put 98 over here, then if I run it, I will get the output as 98. That 98 is now the maximum number. That means it's the maximum value over here. So basically, simple thing we did, we created a function over here called as maximum. We provided with the three parameters, value 1, value 2 and value 3. Then using the conditional statements, we found out which value was greater, that value 1. If the value 1 is greater than value 2 and also value 1 is also greater than value 3, in that case we have created a variable called as largest. Inside that variable we have set the value 1. Now if value 2 is greater than value 1 and value 2 is also greater than value 3, in that condition the variable maximum value will be set to value 2. That means the value which is greatest over here would be value 2, and else if it is not 1 not 2, then definitely it's value 3. So maximum value has been set to value 3. After this we have returned the maximum value, because from this function what we want the maximum value over here. So we inside the return statement we have written maximum value and then we have printed it down. So basically this is how it can be done over here. Moving ahead to our next question over here says, write a Python function to create and print a list where the values are square of numbers. So here we have to create a list in which the values which we will be providing inside the list will be the squares of all the numbers from 1 to 30. So what we need to do over here is, we can clearly see we need 1 to 30 numbers. So 1 to 30, that means we have been provided with the range over here, and the range comes in our for loop. So we will be using our for loop over here to iterate it and add the values. So first of all, we will start with creating a list over here. That definition create list. And I will not be providing with any parameter over here, because all I need to do is iterate through a for loop and add the values inside the list. So as we need a list over here, I'll be creating a list over here. Or you can also write L is equals to open close square bracket. This will be also an empty list, and the way I wrote it before is also an empty list over here. After this, what we need to do, we need to use a for loop, that for I in range, we know we need to go up to 1 to 30. So I'll be writing 1 comma 31. Why 31? Because our for loop syntax says that we need to add one number to our last number. And what we need to do, we need to add these values, the squares of these values inside our list. So we'll be writing L dot append. What we need to append, the square of these values. That means 1, 2, 3, 4, 5, 6 up to 31, the square of these values. So we have to write over here I times I. So you can write I times I, or you can also give exponent to it, that I square, right? And in the end, what we will be doing, we will be returning the list over here. So return L, and lastly print create list. And let's run and see what output we get. We can clearly see that we have got the square of all the numbers up to 1 to 30. So for starting with 1, and the square of 30 would be 900 over here. So all the values have been provided from 1 to 30 over here. So we have used a very simple method over here of functions, inside which we have used list, and also we have used our for loop over here. So basically we have created a list which is an empty list. Then we have used for loop to iterate inside the list. That means if we wanted to add values inside the list, I need a range over here that was given 1 to 30. And every time we have appended what? We have not appended I over here. We have appended the square of I over here every time inside the list. And lastly, we have returned the list over here, and then we have printed it down in the end while calling the function. Moving ahead to our next question over here, that our next question says that write a Python function that takes a number as a parameter and check if the number is prime or not. So we will be taking a parameter over here to check if a number is prime or not. So definition prime, and inside I'll be writing number 1. So I'll be taking this number as a parameter over here, and then we'll be checking for it. Now how to check if a number is prime or not? Our first condition over here says that if a number is equal to 1, then it is not a prime number. So we will be writing if this number 1 is equals to 1. In that condition we will print it is not a prime number. Also, we know that if a number is 2, then yes, it is a prime number. Not talking about all the numbers greater than 2 over here. What we will be doing, I'll be giving a condition that I'll be using a for loop over here to iterate up to that number. I'll be using elif over here because we can use elif And lastly, we will be using else. So what we will be doing basically over here, this else will be containing for all the other numbers. For 1 and 2 we have written. For 1 we have written that it is not a prime number. For 2 we have written already it is a prime number. But what about all the other numbers? For that we will be using a for loop over here to go up to that number. So whatever this number is, let's say this number is 11. So what we will be doing, we will be iterating up to 11. From 2 to 11 we will be iterating. And we will be checking that if any number between 2 to 11 when divided by this number gives us the remainder 0, then it is not a prime number. So we will be providing with this condition over here that for I in range 2 comma up to this number 1, if whatever our number is when it is divided by I and it gives the remainder 0, in that condition we will be printing it is not a prime number, else we will print it is a prime number. And lastly we will be printing the function, and lastly we will be calling the function by writing prime. My parameter over here, that what will be the value to it, so the argument would be, let's say 12. If I run it, I get the output. It is not a prime number. It is not a prime number, but it is a prime number. Okay. So how to fix this is, once if it is not a prime number, we will break this loop over here. And now if I see it says it is not a prime number. I try it for 11. 11 is a prime number, but let's run and see. It says it is a prime number. If I try it for 37, which is a prime number, it gives me yes, it is a prime number. If I write it for 36, which is not a prime number, then it will tell me it is not a prime number. Similarly, R1 will give us it is not a prime number, and 2 will also give us it is a prime number. So this is how basically we have done it. First of all, we created a function whose name is prime, and then we have created a variable over here, that means a parameter, that is number 1. If number 1 is equals to 1, we know that if a number is equal to 1, then it is not a prime number. Secondly, if a number is equal to 2, that means if our number, whatever our number that we have provided, if it is equals to 2, in that condition it is a prime number. Similarly, we have provided with another condition that if our number, whatever number we have provided, is equal to 2, then it is a prime number, because we know that 2 is the prime number. Now, nextly, we have checked for a condition over here that what if a number is greater than 1 and 2. So that means what we will be doing for those numbers, we will be using a for loop over here, that for I in range, we will be iterating from 2, starting from 2 and going up to that number. So suppose our number is, let's say 13 over here. So it will iterate from 2 to 13. That means 2, 3, 4, 5, 6, 7, 8, 9, 10 up to 13. And if it will check for a condition that whatever our number is, so 13 when divided by any number in between, let's say 3 also, it does not give the remainder 0. For 4 also it will check, 5, 6, 7, 8, 9, 10, up to 12 it is going to check, because here 13 will come, no? So 13 automatically gives us 12. So up to 12 it will be checking over here that if it is dividing it and giving the remainder 0 or not. So if it is giving the remainder 0, then it is not a prime number. And here we have break the statement, because what it was doing, it was continuously checking for the other numbers as well. So as soon as one time it tells us it is a prime number, we need to break it over there. Else if it is not giving the remainder 0, in that condition we have printed that it is a prime number. And lastly, we have called the function by providing the value to it as an argument. So this is how this question can be done. Moving ahead to our next question over here. Our next question over here says that write a Python function to find sum of all the numbers in the list. So guys, this can be done in two ways. We have two solutions to this. One solution is using a for loop over here, and the second solution is using recursion over here. So first of all, let's try it with this for loop. So I'll be writing solution 1 with for loop and solution 2 using recursion. So first of all, doing it using a for loop, all we need to do is create a function, definition add, and I'll be providing with numbers over here. I'll be putting a colon. Now what we need to do, we need to iterate with the for loop, that for I in numbers, what we need to do, every time whatever the number is, we need to add it to a variable. So we'll be creating a variable called as total. Total is equals to 0 initially. Okay. And to this total, we will be adding all the numbers that we have provided inside the numbers. Okay. So here we will, inside the numbers, I'll be providing with a tuple over here. You can provide it with a tuple, we can provide it with a list, totally choice is up to you. So I'll be providing over here a tuple, and here we will be writing total plus is equals to I, that every time to the total I will be added. Lastly, we will return the value, that return what? Total. And while calling it, that means we will be writing print add, and you can here provide with a tuple with multiple numbers. Okay, and as soon as I run it, I get the total 69 over here. And if you want to provide a string over here, that the total of the given numbers is, and I'll put a comma over here, and as soon as I run it, I get the output that the total of the given numbers is 69 over here. So simple thing we have done over here, we have created a function. Inside we have created a variable called as total. We iterated it with the for loop over here, that for I in numbers, so whatever numbers we will be providing, so here we will be providing a tuple of numbers. That's why I have created a tuple over here. So we'll be iterating through these tuples, and every time it will add a number to the total, and lastly we have returned the total. And after that we will be calling our function by providing the values that we need to provide it. So this question is also done over here, guys. So guys, talking about our next solution, that means using the recursion. Recursive functions are those functions that can pass a function inside a function. When you can pass a function inside a function, that is called as recursive function. That means when a function calls itself inside it, that is our recursive function. So we will be solving this problem using the recursion. So guys, how we will be doing it? For that, I'll be creating a function called as add, and inside I'll be providing with a sum of list, or we can call it a numbers list as well, because sum would not look nice. Over here is a numbers list because you'll be providing numbers to it. Now what we need to do, we need to use recursion over here. Before that, we need to provide with the condition that suppose while passing the arguments, you have written only one value inside it. Now what will happen in that case? So if len of number list is equal to 1, in that condition we will return it with whatever element is there inside that list. That means if I have written only 5, that means the addition would also be of 5. If I have written 7, then the addition would also be of 7. So what we will be doing, we will be returning with the number lists, that index, that means 0. Now this is one condition, that if our length is equal to 1, if our length is equal to 1, this is one condition. What if it is more? So that means else. For else we will be giving a condition over there, that we will be returning number lists 0th element. That means we will be writing the 0th element over here, plus what we will be doing. So suppose our list is, I'm considering a list over here first of all, that I'll be returning add, and here inside I'll be passing a list of 2, 4, 6, 8, 3, 6. Okay. Now what I'm trying to say is that number list zero's number, that means 0 index will be 2. 2 plus what will come over here? Rest of the range will come over here. That this 2 will be added to rest of the range. So rest of the range could be defined as number lists, and we'll be doing the slicing over here, that 1 up to the end. And because we are calling the whole list and it's a recursive function over here, so we will be writing this add over here. So add, that means we will be calling this for a recursion of number list from these elements. So first of all, what will come? 2 will come plus all the elements over here. So now our next list would be from 4 to 6. Then again after this, if our next number is 4, that means our new list is this one, right? So now our new first number would be 4, and then rest of the list will be added to it. Next is our whole list would be from here 6 to 6, and our first number would be 6, and our whole list will be added to it. So this is how it will keep happening up to the end every time inside the function. So now if I run it, so now if I print it and run it, I get the output 29 over here, that the addition of these numbers that I have provided over here is 29. If I would have written this similar number which I had written previously, it should have given me 69. Let's see if it works with this method as well. So if I write the same numbers over here, it gives me 69. That means it is correct over here. That means both the methods are working properly. In this method, try to understand it again, that what I have done basically, I have created a function called as add. I have created a list over here of numbers that I'll be passing in the end. Next, I have created a conditional statement that if the length of this number list is 1, that means suppose over here I would have written only 5. It would have given me with 5 only. Why? Because what I have given, that if the length of this number list is equals to 1, in that case whatever is there on the index 0, return with it. No matter which number it is, just whichever number is there inside it, return with it. Because if there is only one number inside the list, that means if there is only 5, then the sum of all the numbers will also be 5 over here. Next, we have written if it is not 1, it is more than that. In that means in the else condition, what we will be doing, we will be returning it with this formula, that our number list on number 0, that means 0th element is right now 12th, and 12 plus what we will be doing, we will be calling this whole function again with the new list. What will be the new list? Starting from 1 up to the end. That means we will be doing our slicing, that starting from the 1 value and up to the end. Now what will happen, this 12 will be there with us inside the total. Okay, after this our new list is 4 to 10. That means again we will be providing a recursion on this. That means 4th will become our number over here. So 12 plus 4 will become 16. So 12 plus 4 will become 16 over here, and a new list that will be added to it would be this for our recursion. Then again a new number will be added, that means 5, and this whole list will be provided for the recursion. So this will keep happening up to the end, and as soon as it stops, it provides us with the return in total. That means whatever the addition is. So I hope guys these two methods are clear to you. Moving ahead to our next question over here. So guys, our fifth question over here says write a Python program to solve the Fibonacci sequence using recursion. Let's have a look with the help of an example over here. So what we need to do, first of all we know what is Fibonacci series. It starts with 0 and 1. So 0 plus 1 will become 1. Fibonacci series means the addition of preceding two numbers will be our next number. So 1 plus 1 will become 2 over here. These two numbers, that means if I add these two, it would give me 3. If I add these two, it would give me 5. If I add 3 plus 5, it would give me 8, and it keeps on going on, so on like this, right? So to solve Fibonacci series means what? We need to find the addition of these two numbers. If I have provided Fibonacci series up to 7 numbers, so I have written 1, 2, 3, 4, 5, 6, 7. So what I need to do basically, I need to find the addition of these two numbers, that what these two numbers will give up to the range of 7. If I have a Fibonacci series, what the last two numbers, that means what will be our next number over here. I need to find that over here. Okay, how I will be finding that? First of all, talking about n is equals to 1. Suppose a person has provided that the value of n is equals to 1. In that case, the first value would be 0, right? So we will be returning it with 0. Similarly, if a person has provided with 2, that means they need two values over here, then we will simply return it with 1. Now what if a person has provided with 3, that means n is equals to 3, that means 3, this one will be what? This one will be the addition of this and this. So this value lies, so addition of this and this would be what? N is 3 minus 1, that would be our 2, plus n minus 2, that means 3 minus 1 gives us 2, so that means n minus 2 over here, that means this value would be what? N minus 2, which will give us what? N is equals to 3, that means 0 plus 1 will give us 1, right? Similarly, if I consider a case over here, that if my n is equals to 7, right? So n of 7 would be what? N of 7 would be, according to our formula, n minus 1, that would be our n of 6, whatever our sixth value is, plus n minus 2, that whatever our fifth values is. So sixth value over here is 1, 2, 3, 4, 5, 6, 5, and our seventh value plus 3. So that means here 5 plus 3 will become 8, which will give us our value, or that up to the 7th number till 7 number over here we will get the output 8. So now what we will be doing, we will be applying this same formula in our Python. So I'll be writing over here definition Fibonacci series. For Fibonacci series I'll be writing fs. In fs I'll be not passing any function, but in fs I will be passing a parameter over here, that would be our n. I'll put a colon over here. Now we will be providing with our first condition that if n is equals to 0, in that condition we will return with 0. If I talk about 0 over here, that if I talk about 2 over here, that if n is equals to 2, that means two numbers. So the addition of so the two numbers over here would be what? 1. That means the addition of these two numbers would be 1. So we will be returning 8 with 1. Now talking about else, that means if it is not 0, not 1, then what it would be, we will be talking about that. For that we will be using our recursion method over here, that return with what? We will be returning with the Fibonacci series up to n minus 1, that would be plus Fibonacci series up to n minus 2. According to our formula, this is how it should be done. And I'll be enclosing the whole inside a bracket. Now to call this function, I'll be writing fs, and fs of up to 7 numbers. So this thing should give me 8 over here, because we know we can clearly see the last two numbers. That means up to 7. The last two numbers are 5 and 8. So if I run it, that means n minus 1 would be 5. Plus n minus 1, 2 would be our 3, and if I add it, I should get the output 8 over here. So if I run it, I get the output 8. That means it is working properly. What I meant to say over here was that if our n is equals to 7, and here n minus 1 would be, so 7, 1, 2, 3, 4, 5, 6, 7, n minus would be 5 plus n minus 2, that means our n minus 2 would be what? 7 minus 2, that means 3, that means over here 3, so it would give us with 8 over here. So that's why it's giving us with 8. Similarly, if I would have written 8 over here, it would have given me 13, because 5 plus 8 would become 13 over here. So this is how you can solve Fibonacci sequence using recursion. So I hope guys you have no doubts and no questions after this problem solving. In our next module, we will be starting with a complete new topic. That would be modules. So stay connected guys, and I'll see you in the next session. Thank you.